Ooh, how's everyone doing? Uh, this is one of the most, today I wanted together to talk about one of the most common mistakes that I see new people make when they're first getting into XR UX design. They're just starting out in prototyping in 3D tools. And the biggest mistake that I see people making is that they'll miscalculate or completely miss altogether the scale of the 3D objects. And that's because multiple reasons. Scale is one of the most important things to not mess up when you're creating for XR, when you're rapid prototyping, creating the worlds. And that's because scale affects realism, which then affects your immersion. And immersion is incredibly important for XR and for VR in particular. Hi, Kirsten. How you doing? And not only that, it's also because that we're designing for 360 three-dimensional space, just like we would be designing for physical space. We need to pay attention to the size of objects in relation to our physical bodies. And so scale affects your ergonomics. Like, pay attention to if you're not sitting at your desk properly or something, you're going to get uncomfortable. The same thing can hold true in XR as well. When furniture doesn't fit, things like that, it really affects everything. Hi, Giannis, how you doing? So we need to think about that. And we absolutely don't want to ignore it or mess it up in our XR designs. It affects ergonomics, it affects your neck comfort and your head comfort, which is emphasized more because you have a heavy headset on your head, which then is going to make that neck pain even worse. So we want to pay attention to scale. Hi, Anil, how you doing? So in that slide today, I'm going to talk you through some of the main reasons that scale gets messed up, and then also give you some tips to help gauge scale across various tools. Not all the tools, I'm just going to be talking about Bezi and Unity and SketchXR. I don't know Unreal, but I will give you some resources for Unreal. It's very similar to Unity. So it's a very common issue that I see with prototypes that my students have made, that they'll put a lot of thought into the flow and the interactions and the environment, which is good. You definitely want to pay attention to that stuff. Very important. But then all of a sudden I'll see a UI panel that's like really huge up in the sky. Because when they were creating the UI panel, they weren't thinking about it in relation to the rest of the world. And then you end up having to crane your neck to see it, and then it's like a giant UFO in the sky. And there's also examples of sofas being ginormous, or doors being too high, doorknobs being too high, things like that. And you feel like you've just landed in a world of giants. And if that's what you're going for, good job, because great. But for the most part, we usually want to design to human scale. And if we look at the common denominator of what causes the sizing to be off in XR at its most basic level, it's because the people are just not thinking about it. And to be fair, that people that are new to XR, they don't know to think about it. Unless you've come from industrial design background, 3D design background, or any other type of background where you're designing for three-dimensional space, it's not the first thing you're going to think about. Whether that's physical or digital background, it's not the first thing you're going to think about. And that's okay, and it's usually something that has to be taught. Yeah, you've been guilty of that as well. Yeah. That's okay. It has to be taught. So for digital spatial design, the most common reason why bad sizing could happen is that the 3D models themselves aren't sized appropriately when they're created. And if we're not aware of that, we could assume that the 3D modelers took the time and the effort to create those models at scale, at the appropriate size of real life scale. But Like oftentimes, especially if you're using free assets, that's not the case at all. So regardless of whether you're creating the 3D models yourself in a 3D modeling tool or downloading them from the internet or creating them inside your prototyping tool, which you can do as well, you have to keep an eye on the model sizing and the scaling and the size of your world. And you can't just assume that if you pay for a 3D model or get one from one of the main sites like TurboSquid or Sketchfab or one of those big sites like that, that it's going to be accurately sized. So I'm not going to teach you 3D modeling. There's plenty of resources out there for that. And I have some resources in the show notes that if you want to check those out later, you can, that teach you how to create models at scale in Blender, the free tool for 3D modeling for those that want to learn that. But the too long didn't watch version is that you want to use the features that are at your disposal within the various 3D tools to create the objects that are sized correctly. And that includes things like snapping grids and dimension annotations and referencing real-life objects and measuring the real-life objects and paying attention to those. And also paying attention to the unit of measurement that's being used in the tool that you're using. For the most part, it's metrics, not feet and inches for those in the United States. It's most of the time going to be metrics, meters. And I'm going to focus on the prototyping aspect. So let's say that you found a 3D model and you love it, but it's not sized correctly. And it's easy to fix. Easy to fix. It's not the end of the world. You don't have to trash it. You can still use it. And it will vary by the tool that you have. And I'm not going to teach you how to use the prototyping tools. I'm just going to teach you tips and tricks that you can use to understand scale and to fix these common issues within these tools. And so we're going to start with Bezi. And how many of y'all have used Bezi before? I personally think that this is the easiest tool to learn for designers. If you're coming from a non-3D background, you've just been doing 2D UI, this is one of the easiest tools for you to learn because it's very similar to Figma and other design tools that you're used to, except it has the added feature of 3D. So I don't have anything showing in my scene right now, but you should be able to see this grid that's on that's in the scene, in the 3D scene. So you dabbled in it a while back. Yeah. It's pretty simple to learn. So you'll see that there's this grid on what is the ground level of the space. And you'll see a blue and a red line. This is where the X and Y axes meet. That Z. That's X and Z. And if you see over here in the corner, you'll see the X axis, the Y axis, the Z axes. These are color-coded to match what you see in the space as well. This X is red, you'll see X is red. This is called a gizmo. And you'll see that there's a bunch of boxes here. So these are set to whatever the unit of measurement is that your grid's set to in your tool. And if you look over here in this properties panel, down at the bottom here at personal settings, you'll see the grid, it's set to XZ, but you can change it to XY. The Y goes up and down. You can see that in the gizmo here. You need a reference. And then X and Z, just another like axes to work with. And most of the time you're going to want to work with X and Z. And then you'll see that it's set to snap to the grid. And you want to use these tools to snap. You'll see this little, you can show and hide the grid here. And with this little eyeball that's next to the grid word. Can y'all see well my mouse? I have made it bigger, but let's see. It's not gonna zoom it in. I can't make the UI any bigger. But then you'll see this little magnet here that lets you activate or deactivate snapping to the grid. And snapping to the grid is very beneficial, especially if you're creating objects within the world using primitives or built-in tools. And then units. One thing that's very different, and it's a nice feature in Bezi that's not available in the other tools, that the most common tools, is that all those tools use meters or centimeters, but Bezi lets you choose between meters, centimeters, millimeters, feet, and inches. So this grid matches whatever you have chosen. So if you have centimeters, that grid's going to change, and you're going to have a whole bunch of tiny little squares in there at the centimeter level, and so forth. Change it to feet or inches. So for those in the US, you don't have to do the math, the conversion math, but the rest of the world still has the option of meters. I'm in the US, so I'm going to switch to feet. So pay attention to those options and know what is being used in the tool that you're using, because that's going to really come in handy for when you're paying attention to the size of the objects, because this grid's going to let you reference, okay, this is so many feet wide or so many meters wide, so forth. That's going to help. So I'm going to add, the nice thing about Bezi to compare objects for scaling is there's a different trick for each tool. But in Bezi, they actually have a human model that's set to average human height that we can use to reference for sizes in Bezi. So I'm going to add a human. I'm just going to type H, and then the menu shows up. And I'm going to type HUM, and that's going to let me add a human to the scene. So here's a human, and if you look over here at the size, it's set to average human male height of 5.75 feet. So that's a good reference, and you know, if you're creating for a different average height, then you can resize your model to fit appropriately, but make sure that you have your little proportions constraints option selected over here. It's on, it's off right now. Okay, so I'm going to go ahead and constrain proportions. And let me know if you have questions. So this is the human height, and if we look over here in the properties panel for this human, you'll see that we have height here 5.75 feet in actual measurement, but if we look up here in the transform, we have scale 1:1:1. And it's very important to know that with 3D objects, size does not equal scale. So the scale is in relation to the actual original size of the model or 3D object, not the unit of measurement. So if we wanted to make a human that was twice the height of this model, we would just type in, we won't have to do math to make the change. We just have to type in here, I want it twice the size. So I have 2 with the constraints, with the proportions constrained. And so now we have a human that is twice the size of the original model. Does that make sense? Let me know if that is confusing to anyone. So they're not a match. It's based on the original size of the model, whatever that was created at. And it is different in Unity and Unreal because Unity and Unreal don't have the size showing. They only use scale. So then you're going to have to do some conversions and figure things out differently in Unity and Unreal. So another thing to know, that there's a difference in using the primitives and 3D models. So let's see, scale and size always trips you up. Scale is something that you think as a normalized version, convenient for modelers to deal with size. Size is the real deal. What do you mean by that? And it makes sense. It's actually very similar to Figma. Okay. Yeah, they created it pretty similar to Figma. But these, like, transform your XYZ axis. Like, if you pay attention to traditional design tools, you'll have an X and a Y, but Z's new because it's 3D. So you just have that extra dimension of space with the 3D tools as opposed to 2D tools. And so let me demonstrate. There is a difference in primitives that are made in the world and models that are created and brought into the world. So for the models that are created and brought into the world, you can see if I double the size, the scale, you'll see that the size didn't change. It's just the scale changed. This is different than how you would think about pixels in 2D. So this is more about physical scale, which is an old concept from industrial design, architecture, and so forth. So I'm going to add a cube. Sorry about that. I bumped the back button on the side of my mouse on the keyboard. Okay, there's that human. And let me just add a cube real quick. I'm going to type in B for box. And so since I have grid snapping on, I can create an exact size that I want. So if I want a 1 foot by 1 foot cube, it's going to automatically snap to that size. And now I have a 1 foot by 1 foot cube. And you can see here 1 and 1. But if I resize it, the scale's changing, but it's not changing the actual height, but it's changing the Y scale. So this is going to be referencing, the scale is going to be referencing whatever it was that you created it at the original size in the tool. In this case, in Bezi. A little bit different in Unity, I think. Normalizing means making it convenient for working purposes. So 3D platforms imports model as scale of 1, although the size could be 5 meters. That's what O'Neill says. Okay. So I'm going to demonstrate now the problem with 3D models. I'm going to insert I've already inserted a sofa into the scene. I imported it, but you can import 3D models into Bezi. But if you notice, here's my human at actual human height. And there's the sofa. If we zoom out and look at the sofa, there's the sofa, and there's the little human. Size of an ant. And I've actually had that happen before. A student had imported a model into their world, and they knew they imported the model. It was there and everything. But whenever they would hit play to look at the prototype, they couldn't find the model. The reason that they couldn't find the model was that the model was the size of a house. But they didn't realize that. So this is the biggest problem that people have whenever they're importing models into a 3D scene, because the original model creator, even though they made this beautiful sofa, it's actually not real size. But if we click on it and we look at it, it is showing it's a scale of 1 to 1. But if we look at the size, because Bezi shows you the size, it's 124 feet high and 262 feet wide. Anil is saying, Kirsten, if you look at the scale of this sofa, it's 1, 1, XYZ, and it's same for the human, but their size very different. Yeah. Yeah. So how do we fix this? Well, Bezi makes it a little easier because they do reference size. So you don't have to do a bunch of calculations to figure out, okay, how do I get this sofa down to the right size? Bezi's nice because you can just approximate, okay, I'm going to start out with a sofa that is 4 feet high, and that's going to make it easier for me to go in and look at it. So I just went into this and typed in 4 feet. And now the sofa is way smaller. And if you look at the scale now, it's at 0.03 scale of the original size. And it's a lot closer to an actual sofa size. But if we, not everyone's going to know this. I come from an interior design background. I have education in interior design. And I know that ergonomically and so forth, furniture design, the back of the knee of an average adult male is where the seat height should sit. Y'all are giving some good tips in the chat. Keep it up. So Yanni says, I understand that size is the measurement of an object's physical dimension, while scale is the relative size of objects in comparison to each other. Yes. Their dimensions make sense between them. Yeah. And so now you'll see that this sofa is at 0.03 scale because it's at 0.03 of the original sofa size. And now we can bring the human over and adjust it to where back of the knee is where the seat height is. And so you don't have to have a background in interior design to do this. You just look at real world objects and measure them. And you can see how in relation to your body height, you could change the height of a 3D model to fit your body height and then work off of that if you're not, because I'm absolutely not the size of an adult male. I'm 4'10". I don't know what that is in meters, but definitely not the same scale. So if you're different height, you can just use the real world as your reference, use your units of measurement, and make your changes based on that. You don't have to have a degree in interior design or anything. And then we can resize it down a little bit more. Let's try 3.5 feet. And that's a lot closer to the actual size. Depends on what kind of cushy sofa you want. If you want a really cushy sofa, and so yeah, 3.25. Or you could use the gizmo to change your height that way as well. And get it to where, so this is pretty close to the actual size. And if we look at it here, it is 3.3 feet by 6.8 feet wide by 3.3 feet high, which is a much more realistic sofa. Any questions on that? Hey David, how you doing? It's been a while. Yeah. Any questions on that? And so you just pay attention to your real world objects. Keep it. I have multiple tape measures that I keep around to measure things and to know the scale of objects and stuff. But I also build furniture, so I have lots of experience with that. Let me know if you have any questions. And yeah, so did that make sense to everybody? Same scaling, but different sizing. Yeah. Okay, now we're gonna switch over to Unity. And it's very similar in Unity, except they don't offer the little size feature that shows you the actual feet. Let me switch over. Okay, so y'all can see Unity. Same thing you'll see in the world. Again, I'm not going to teach you Unity, but it's similar to It's pretty similar to Unreal. I don't know Unreal, I know Unity. But you're gonna have the grid options. They're just gonna look a little different. And you're gonna have this surface level. You're gonna have a gizmo up here in the corner that shows your X, Y, and Z. And the colors may be different, but if you'll notice in here, there's no red and blue lines on the grid showing you where the perfect center of the world is, like it does in Bezi. Are you talking about the scene transition? What are you talking about? So same thing in here with, but the location is up here in the scene window. You'll see there's an X or a grid with a Y on it. And then there is a grid with a magnet on it. So similar icons, magnets, and so forth. But you toggle it on. Can you see the difference in the blue when it's toggled on and off? It's not as obvious, I think, especially if you have like color blindness issues or sight issues. But there is you can adjust your color settings and so forth in Unity as well. But toggling it on and off is going to be blue when it's activated, so you can see the grid or not. You just toggle it on up here in the scene window, and then you toggle on that snapping right next to it, and it's going to be blue when it's on and gray when it's not. And if you click on the little arrow next to the two options, you'll see additional options so you can show the grid on your different XYZ planes. It's default. Just usually leaving it on default is good. Usually that's great. But if you're going into more detailed stuff, you might want to utilize the other axis of the grid. But I usually just leave all these settings on default and they're fine. And you can choose your snapping options here as well. I just leave it all on default. And you can activate snap to grid with the checkbox or with the blue toggle. And so in Unity, they don't have that human model built in. So you would have to get one from like the asset store or somewhere, and hopefully it's the right size. Yeah. So I found one that is the right size, and I have a link to it in the show notes. If you do use Unity or Unreal and you want a model that's the actual size, I have a link to one in the show notes. It's available on that Unity asset store, but you can export it if you want to use it in other. And that is the human base mesh male that I'm going to go ahead and activate in the scene because it's already placed in here. So this is set to the actual height, but with it selected, you can see that there's no size option here like there is with the built-in Bezi. So all you have is scale. But if we know that it is the actual size, then that's good. We can use it as our reference. And if you see, since this is set to meters, if you're not sure that something is the right size, this grid is set to meters. So if you see, this is where the changing the grid would come in handy. He is just under 2 meters, which means this is a good average human height, just under 2 meters. And so that's where that grid would come in handy, changing the axes. So we know this is about the right height for a human. Okay, but because we can't know the actual size of the model in here. You might be able to take it into Blender or something and figure it out that way, or there may be a plugin that you can use here that I don't know of. If y'all know of one, let me know about it. But that's the trick if you don't have any of those options. So now same thing with our sofa. There it is, really huge. And we're gonna have to resize this thing. So we can use the built-in scaling tool in Unity to resize it, or we can guess and type our proportions of scale in here. If you get used to scale, you'll be able to experiment. You just type in a number, and if it looks wrong, just keep typing numbers until it gets close to what you think. But I can look at the preview down here to see getting a lot closer to what the actual human height is. And so now we can fine tune it to get it to the actual height, which is just at or below the knee height of the average human male. And so we'll see that it's around about 0.02, which is around about what it was in Bezi. And there you go. There, your furniture is scaled to the right height. Let me know if y'all have questions about that. And that's how you do it in Unity. You just need a reference. But there is another method of doing it in Unity, the old school way, if you don't have a human model. And that is to use a primitive. So let me give you a primitive 3D object. Usually people use a capsule or a cylinder. And by default, the capsule or cylinder is, here, we'll do it again. By default, the capsule or cylinder is going to be about 2 meters high, because you can see if you change the grid, you'll see that it's about meters high. And then you can just adjust the height as needed to make the height. But if you have a human, that's even better, because you're going to be able to tell a much better reference for size. And then you would just have to guess where are the knees to scale it. So those are the two options that you have for Unity and Unreal. And I think Anil said that they added a built-in human to Unreal, didn't they? But I have some Unreal resources for you in the show notes. I have a bunch of resources for you in the show notes if you check those out in the description, to learn more about the scale and all the different tools that I'm talking about. It goes into a lot more depth about what these things mean. And you'll see, though, that I've scaled it down to 0.9. It's round about human height. But it's better to have a... Unreal has a default mannequin that uses 180 centimeters, which is about 1.8 meters. Which is 1.8 meters. And whatever that is in human, in feet and inches. Around 5 points. Well, it's going to be taller than 5 feet, right? It's going to be about 5.7-ish. Because if 5 feet were the average human male, I would be normal. Just slightly under normal. I'm 4'11", 4'10", 4'10 and a half. Okay, any questions on Unity Unreal? And while y'all are typing, I'm gonna switch over to talk about shapes. It's almost it. Yeah. Over to shapes. Okay, ShapesXR, I'm talking about the VR version. There is a new desktop version, but it's very, very new. There's not a lot of features yet. It's not desktop, it's browser-based version. It's very, very new. There's not a lot of features in there, so you don't have a lot of options for like scale and stuff in the desktop version. So I'm just going to be talking about the VR version. I'm not going to get into VR to talk about it because I've already got multiple high-powered software open, and I don't want to add another one by adding VR. So we're just going to use videos to show you what I'm talking about in ShapesXR. I want to quickly go over the features that they use for scaling and sizing in there. And the settings menu, you can find it's by default open on your non-dominant hand, which you can set up when you set up shapes for the first time. is the little cogwheel here is where your settings options are. And in the settings options, you can turn on the grid to show the grid on the ground in there. And then your snapping options are going to be under the select tool options, where you can come in here and set how you want your dimensions to snap and so forth, like increments and so forth, for your snapping, for your rotation and your movement of your objects through the world and in relation to each other and so forth. This is where you set up those settings, which are very useful when you're creating from scratch in the world, which you can do a lot in ShapesXR. They do also have a human model included. And the really cool thing about ShapesXR, as opposed to all of the other tools, is that you can use yourself as a reference for scale, because it's being created in VR with you in the world. You're not looking at a 2D screen. You're immersed in the world while you're creating it, kind of like you would be in real life. So that's really cool. But it's very, very important to remember, though, and this is where students get new people to ShapesXR, and students get messed up, and they mess up the scale, and you end up with a UI that's 10 feet wide up in the sky, is that they're not paying attention to the scale of the actual world, because you can zoom in and out of the world in ShapesXR, make things really small and really big by zooming in and out. So if you look, when you grab the grips on the controllers, the grip buttons is how you zoom in and out. You grab two controllers and you zoom in and out by squeezing and, stretching. And if you pay attention when you're doing that, you'll see there's this line that shows up between your two controllers, and it says your scale is something %. If you're wanting to create something that is actual size, you need to make sure that your scale is 100%. That's the big problem that a lot of people have. They'll zoom out and they'll be working on the world really small, but then they'll forget and they'll make a UI or whatever that's really huge. They think they're making it at the right size because they're making it in relation to themselves, and then they'll forget and it'll be at a completely wrong size. So just make sure that your scale is at 100% when you're wanting to create something that is of actual size. Or use the human model that's built in to the tool. Has anyone here used Shapes? No, Kirsten. Let me think. Even cooler about Shapes is that you can use pass-through with Shapes with your quest to see the actual worlds and use it as a scale reference. But again, you have to make sure that your scale's at 100% and you turn on pass-through. And you can turn on pass-through if you look at the left controller, your non-dominant hand controller. You'll see the bottom button down here it says MR on it. And that's how you switch to pass-through so that you can see the world and the digital objects that you're creating. And then if you're do I have a picture of that? Let's see if I have a picture of that. You can set up to where you're anchoring your world to the real world so that you don't accidentally move the world and mess up your scale with pass-through. Let me see if I have a picture. I think I have it in the show notes. I do not. Okay, fine. Let me just look. Mixed reality and pass-through. If you just go into their Learn Shapes, you'll find it mixed reality mode, room scale mode, and you can paste it in the chat here. and you can anchor your digital world to your physical world so that you can then trace or size your objects in relation to the real world if you need to. And that makes it a lot easier for you to create scaled objects. And that's regardless of whether or not you're going to be creating a mixed reality or a VR experience. It matters for any kind of XR. You want things to be, depending on the goals of your project, of course, you're going to want things to be at the right scale. So this is a great method that they've built in place for you to be able to do that. Any questions on that? And then you also still have the traditional resizing that you have with the gizmos and stuff. And the reason that I went through all of this today is that I'm working on a new VR training design course, and we'll be covering rapid prototyping in the course. And I wanted to make sure that our students are aware of these common issues so that whenever they're creating rapid prototypes, they will avoid these mistakes. But I want to make sure that the information that I provide in the course is correct, and Neil's helping me work on the course. We want to make sure the info is correct. So if I missed something or if I got something wrong, let me know in the comments. And we'll fix that. Or if you have extra resources for other tools, I got a message in LinkedIn about a new tool that I haven't heard of that I got the name of already. But it's a new tool I want to check out that's made by designers for creating XR experiences. That if you know, like, what are the tips and tricks for this, let me know. And I will make sure those things are included in the course that we're creating. Let me know in the comments or now or LinkedIn or wherever. And if you want to learn more about these different tools, again, I have links in the show notes for you to check all that out. I have a bunch of resources in there, and there's also a link in there to sign up to get updates on the status of the new VR training design course. Yanni says, I'm just new to this world, so everything is a gold mine for me. Thanks for that. You're welcome. You're also welcome, Kirsten. Thanks to everyone that hung out with me today. I hope it was helpful, and I will see y'all next time. Y'all have a good rest of your week.